This recording is about mass-mass stoichiometry, which is pretty much the basic type of stoichiometry problem that we usually do. And we start with the mass of our given formula, what we're given information about. We convert to moles, and then we go from moles to moles of what we want or our unknown, and then back to grams, back to mass. These are the basic 3 steps that we always do. So to solve a mass-mass stoichiometry problem, the first thing that you want to do is write a balanced equation if you don't already have one. Make sure that it's balanced. Convert the grams or mass to moles of your given substance. Use the mole ratio to find the moles of what you're looking for, and then convert from moles back to grams of what you want. And so we call this a sort of roadmap. Grams are a given. Divide by molar mass to get moles, use the mole ratio to get moles of what we want, and then convert from moles back to grams. So the first step is make sure that your equation's balanced. Balance it if it's not. Calculate the molar masses of all the formulas. Make sure that in your molar mass you don't include the coefficients. So magnesium here is just 24.31. We don't multiply that by 3. It's just the molar mass of the formula by itself. Again, same here, magnesium oxide is 40.30. We do not multiply this by 3. It's just the formula molar mass. Okay, so in our basic stoichiometry problems, again, start out with grams of our given 3.56 grams of magnesium. Divide by the molar mass of magnesium, grams on the bottom, because it has to cancel. And then moles on the top, moles of magnesium. In the next step, we convert from moles of magnesium to moles of iron. Moles of magnesium is going to go on the bottom because it has to cancel. And then in the third step, convert back to grams, multiply by molar mass, grams per mole. Moles of iron is going to be on the bottom because, again, it has to cancel. And then once it's all set up, plug the whole thing into the calculator. 3.56 times 1 divided by 24 times 2 divided by 3 times 55. And that gives us 5.45 grams of iron. Don't forget that the unit that doesn't cancel at the end is the one that your answer has. The next one, how much iron oxide, that's what we want to find, so that gets the W, will be needed to make 8.92 grams of magnesium oxide. So that's our given because it's what we have the numbers for. So start with that one. Grams of MgO, convert to moles, use the mole ratio. MgO is going to be on the bottom because it has to cancel. Moles of iron oxide is on the top, and then convert back to grams. Molar mass is going to be on the top. 11.78 grams of iron oxide. So stop the video and go through and work these out on your own, and then turn it back on and check your work. So here's our balanced equation. It is already balanced for us, so we don't have to do that. Calculate the molar masses. I always write them right above each formula because that way I know which one is which. Don't have to label them, and that they're easy to find when we need them. And then starting with 15 grams of our given, which is NH3, convert to moles. Use the mole ratio, which in this case is 4 to 4, because the ratio is 4 moles of NO to 4 moles of NH3. And then convert back to grams of NO and the answer is 26.4. Starting with 20 grams of water, convert to moles, use the ratio, convert back to grams for oxygen, and we get 29.6 grams of oxygen. So again, go through and balance these reactions and calculate the molar masses, and do the math, and when you're done, then go back and check your work. So in B here, I forgot to circle the given and what we wanted. 25 grams of iron 3 chloride is our given. It has the numbers. And then what we're looking for, what we want, is chlorine gas, which is Cl2. The answer is 16. So hopefully you start to see that most stoichiometry problems, mass-mass stoichiometry problems, have the same basic pattern. Start with grams, convert to moles by dividing by molar mass, use the mole ratio, convert back to grams for the answer. It's really tempting to just write the numbers in and not write all the formulas, but the formulas are really useful when things get tougher and to help keep you from making mistakes or catch mistakes if you make them. So continue to go through and make sure that you label all your numbers as you go.